Hi, my name's Marco Carr. I'll be your host for this training program. I've worked for large and small companies on construction sites like these around the country. I wish I had the time to tell you how often I've been involved in injury and fatality investigations related to excavation safety. What I can tell you is that a lot of what you're going to hear today, whether it's OSHA requirements, company policies, or my recommendations, are based on actual tragic facts. Things like rigging failures, trench collapses, electrocutions happen quite frequently. People die on construction sites every day. A friend of mine lost his brother when a retaining wall collapsed. The vast majority of these injuries and fatalities are preventable, but it takes a great deal of pre-planning, communication, and training to ensure that everybody can go home safely at the end of the day. First, let's talk about three important definitions. An excavation is any man-made cut, cavity, trench, or depression formed by the removal of earth or soil. That means either mechanical or hand removal. You may have heard the terms excavation and trench used interchangeably, but there is a difference. A trench is an excavation that's deeper than it is wide, and usually not wider than 15 feet. Bottom line is that nearly all trenches are dangerous if not protected, due to the fact that they're narrow and you can get trapped. Some excavations, however, especially on large building sites, may only be dangerous near the slopes. It's important to know the difference and to always be on your toes. You've probably heard the term competent person. I'm the designated competent person on this job site. It's my job to identify existing hazards or to predict hazards that may occur in the excavation or in the surrounding areas. Every day I have to take a close look at the conditions of the site to make sure that all the protective systems are keeping workers like you safe. I've got to determine whether working conditions are unsanitary or hazardous to workers, and it's my duty to take prompt corrective measures to eliminate any danger. Basically, it's my job to make sure that you and your coworkers can do your jobs safely. Did you know that cave-ins are the leading cause of death in excavation work, and that collapses are 18 times more likely to result in death than common construction accidents? Cave-ins aren't the only dangers involved in excavation work, though. Other hazards include water accumulation, the collapse of nearby structures, and hazardous atmospheres produced by toxic gases in the soil. That's why if you ever think that there's a potential danger of a collapse or any other type of hazard, you must tell your supervisor, foreman, or the competent person immediately. I can't stress enough how important it is to speak up. With all these potential hazards looming on a job site, no one's going to get upset if you're being overly cautious. You could be saving someone's life, possibly your own.
An employee was installing a small diameter pipe in a trench 3 feet wide, 12 to 15 feet deep, and 90 feet long. The trench was not shored or sloped, nor was there a box or shield to protect the employee. Further, there was evidence of a previous cave-in. The employee apparently re-entered the trench, and a second cave-in occurred, burying him.
Since cave-ins are the most common and the deadliest hazard in excavation work, let's look at them a little more closely. When dirt is removed, the surrounding soil becomes unstable and gravity forces it to collapse. When soil or rock falls or slides into the excavation, the cave-in could entrap, bury, or otherwise injure and immobilize people working in the excavation. Most cave-ins occur in trenches 5 to 15 feet deep and occur suddenly with little or no warning. On average, about 1,000 trench collapses occur each year in the United States, and over 95% of injuries occur in trenches without any protective systems. Did you know that only 2 to 3 feet of soil can put enough pressure on your lungs to prevent you from breathing? In as little as 4 to 6 minutes without oxygen, you can sustain considerable brain damage. And within 10 minutes, well, it might just be too late. In fact, the chances of a trapped worker being killed can be as high as 50%. Trench work is serious work and can have serious consequences if it's not done correctly. Soil conditions can change and shift, so they must be constantly evaluated. There are certain factors that could change the surroundings of the site, making a cave-in more likely. For instance, it rained here last night, and water could potentially affect the state of the soil. So I constantly check the condition of the soil and of the surrounding site and evaluate any condition that may increase the likelihood of a collapse. If you're the designated competent person on site, that'll be your job too. But it's also important for every worker on site to know and recognize some of the most frequent problems and to communicate them immediately. Water is one factor that can increase the risk of a collapse. Other factors include temperature change, vibrations from heavy equipment. Even the surrounding load, like a spoil pile, can affect the conditions of the excavation. Also, a lot of the soil that we work in has been previously disturbed. Previously disturbed soil is different from soil that's never been excavated. It can contain backfill or other materials that can rapidly break away from native soils. Sometimes there are visible warning signs around the excavation that can be spotted before a cave-in occurs. And if you're aware of these warning signs, your chances of getting out before a collapse increase significantly. Some of these visible signs may include ground settlement or narrow cracks in sidewalls, slopes, or the surface next to the excavation. Flakes, pebbles, or clumps of soil may separate and fall into the excavation, or there may be changes or bulges in the wall slope. If you notice any of these signs, get out of the excavation immediately and get your coworkers out too. A life is too high a price to pay to overlook any one factor or warning sign. Cave-ins are possible, they can happen if you're not careful, but they can be prevented. And let's face it, preventative measures take a lot less time and effort than an emergency retrieval. There are different types of cave-ins that happen in various types of conditions. For instance, a spoil pile slide is probably the most common type of cave-in. It occurs when dirt is piled too close to the edge of a trench. A shear wall collapse occurs most frequently in clay or layered soils. Part or all of one side of the wall begins to crumble into the trench, along with the weight of the spoil pile. The height of the falling soil is added to the weight, generating a great deal of force. An average collapse of 2 to 3 yards of soil can weigh 4,000 to 6,000 pounds, or nearly the weight of a pickup truck. A lip slide may be an indicator of a potentially more hazardous collapse to come. A belly slough often occurs in areas near underground utilities or where running water is present. This type of slide occurs when softer soil weakens under the more stable soil. The collapse can be rapid and usually buries or traps the victim quickly. The resulting overhang makes rescue more dangerous and difficult as well. Telltale fracture lines often appear near the bottom wall of the trench before a belly slough occurs. Boiling and heaving and squeezing are two other types of soil conditions that need to be taken into consideration when working in a trench or excavation. Boiling is marked by an upward water flow into the bottom of the cut, creating a quick condition, like quicksand. Heaving and squeezing is a downward pressure created by the weight of surrounding soil or adjacent equipment that causes a bulge in the bottom of the cut. Both boiling and heaving and squeezing may contribute to or indicate a potential collapse, and both conditions can occur even when support systems have been properly installed. Your safety and the safety of your coworkers is the number one reason why the right type of protective system is used for the soil that you're working in. But before you choose a protective system, you have to test the soil to determine what type it is. Now, not all dirt or soil is the same. Solid rock is most stable, and sandy soil is the least stable. You've probably heard that soil falls into 4 types: solid rock and types A, B, and C soil. Let's talk a little bit about what these classifications mean. Solid rock, in most areas that I've seen it, requires explosives for removal, and it becomes a lot less stable when you blast it. In certain cases, you can scrape away at it with frost hooks or vibratory hammers. But for the most part, solid rock isn't something that we work in on a regular basis. Type A soil is stiff and cohesive without fractures or cracks. A few examples might be caliche, typically found in the southwest, or hardpan, also called glacial till. Now, you'll know this soil if you've worked in it. Hand digging is backbreaking. And if you've worked in these soils, you also know that their condition can change quickly. Caliche can be seamy, and hardpan turns to slop when it gets too wet. Now, it's important to keep in mind that no soil can be considered type A if it's fissured or cracked, or if it's subject to vibration of any type, or if it's been previously disturbed or has seeping water. If the soil is part of a sloped or layered system where the layers dip into the excavation on a slope of 4:1 or greater, the soil can't be considered type A either. These layers could slide off of each other, causing a collapse. The problem is it can be difficult to determine which way the layers run. Type C soil is the most granular, like sand or gravel. And type B is somewhere between types A and C, like subsoil or silty sand. Even some crushed or blasted rock could be classified as type B soil. Sometimes soil may have to be reclassified if the conditions affecting its original classification change in any way, such as with the addition of water from any source. Now, many times we're digging around existing utilities as well, which increases the potential for collapse and for changing soil conditions. This is especially true with bedding materials used for most utility installations. Now, there are some inherent problems in classifying soil as anything other than Type C. You have to be careful because sometimes soil is layered. There may be a Type B soil on the surface, but a few feet into the dig there might be a layer of Type C soil. And how frequently do we find water on job sites? These conditions point to classification as Type C. So soil should be treated as if it's Type C unless proven otherwise. There are several ways to classify soil. Test bores taken before work begins provide a good indication in advance of the type of soils to expect, but you can't just rely on lab results. Out in the field, besides looking at the general excavation site and its surroundings, as the competent person, I have to perform a visual analysis of the soil itself. I check the composition of soil samples to see if the soil is granular or cohesive. I look for cracks and spalls in the sides of the excavation and around the adjacent surface area. I also check for existing utility lines and any other underground structures, and for any previously disturbed soil in or around the excavation. I also need to look for sources of vibration and surface water. Each one of these factors can affect the excavation stability and influence the type of protection needed before you get in. Manual tests must also be performed on soil before excavation begins, and there are a number of methods that can be used. Some of the methods test the cohesion of the soil, or how well it sticks together, and other methods test the strength of the soil. The thumb penetration test is probably the easiest soil test. All you do is press your thumb firmly into the soil. If your thumb doesn't go any further than the length of your thumbnail, it's most likely a Type B soil. If your thumb penetrates the full length of your thumb, then it's probably Type C soil or very granular. The problem with this test is that it can be very subjective. When I need to document my test results, I usually use a pocket penetrometer because it gives a reading that's easily interpreted, and it's typically accepted in the engineering community. But even this device has its shortcomings. You have to try to avoid rocks and other particles that could influence the reading, and you don't want to test in an area where the soil's obviously been disturbed. It's important that the reading is taken in fresh samples, typically right from the spoil pile. You insert the shaft about 1/4 of an inch into the soil with smooth, constant force, and take the reading from the indicator ring here. The limited accuracy of manual tests is one reason why many contractors have a policy to simply classify everything as Type C. This can be a costly and time-consuming policy to implement, but it definitely cuts down on the variables and the arguments about who classified what and why. I should probably also talk just a bit about documentation. While OSHA doesn't require that these visual and manual evaluations be documented, it's a good idea, especially on the off chance that something bad does happen on site. Many contractors use a daily inspection form like this one to document their safety efforts. Once you've finished performing visual and manual tests and you've established a soil type, then you can determine what type of protective system you'll need. If your company automatically assumes Type C, then that planning process has already begun. There are various types of trench protective systems to meet pretty much every type of soil condition. Protective systems protect workers from cave-ins, from material that could fall or roll from an excavation face or into an excavation, or from the collapse of adjacent structures. Protective systems are required in nearly all excavations. Now, selecting a protective system for an excavation depends on soil conditions, the depth of the trench, and environmental conditions surrounding the site. One thing that's for sure, though, a registered professional engineer must design protective systems for excavations any deeper than 20 feet, no exceptions. You can slope or bench an excavation, which means cutting away and angling the excavation face, or you can install support systems like trench boxes or shoring. When you slope an excavation, you cut the sides back to a safe angle using relatively smooth inclines. The safe angle used in sloping and benching, known as the maximum allowable slope, depends on the type of soil that's being excavated. For Type A soil, the maximum allowable slope is 3/4 to 1, or about 53 degrees. Type B soil is 1 to 1, or about 45 degrees. For Type C soil, the maximum allowable slope is 1.5 to 1, or 34 degrees. The maximum allowable slope varies for layered soils as well. Basically, as you can see, the more granular the soil, the more gradual the incline. Benching is similar to sloping, but instead of smooth inclines, you cut the sides of the trench wall back using a series of steps. Again, the angles for benching depend on the type of soil. One important thing to remember, though, is that you can't bench Type C soils. They just won't hold the bench properly, and they could collapse. Many times, trenches are in narrow places or roadways, so sloping and benching aren't options. In these situations, support systems like shoring or shielding are typically used. There may even be instances where you may have to combine sloping or benching with a support system. Shoring structures are typically made of metal or wood. They're designed to support the sides of a trench and prevent soil from caving in. They basically consist of plating held firmly in place with expandable braces. There are many types of shoring systems. Some of them are easy to install and others require quite a bit of experience and engineering. Before wood or timber shoring is installed, proper sizing and spacing of the cross braces, uprights, and wales has to be established. The proper size and spacing of shoring components are determined based on the type of soil, the depth, the width of the trench, and how much space is actually needed between the cross braces to perform the work. Other types of shoring may include aluminum hydraulic systems, driven interlocking sheeting, soldier piles and lagging, pneumatic shoring, and screw jacks. Shoring systems have their advantages and disadvantages. For example, shoring can be custom tailored to the trench. It can be used in narrow confines and is typically easier to install around underground utilities. However, shoring requires a greater technical knowledge to be installed correctly, and portable shoring systems are typically not suitable for deeper excavations. Shielding structures, or trench boxes as they're often referred to, are placed inside trenches or excavations and are strong enough to protect workers in the event of a cave-in, so long as the workers are within the confines of the box.
I have experienced a trench cave-in where a brother union member and myself were in an excavation, and the trench caved in on the opposite side of the box, and luckily the person that I was with got into the box in time before he was crushed. The one suggestion that I would make to all members of all trades is training. Training is key. Training, training, training. Always come back. There's never too much safety that you can learn.
Shielding systems also have advantages and disadvantages. They're designed to be moved along the trench as the work progresses and can usually be installed faster and used in deeper trenches than portable shoring systems. But on the other hand, the size, weight, and bulk of a typical trench shield make transporting them to the work site as well as within the trench difficult. Whether you use shoring or shielding, it won't protect you if you aren't inside it. Remember, if the excavation is more than 20 feet deep, the entire excavation protective system has to be designed by a registered professional engineer. We can't just throw something together. I should also point out that manufactured systems like hydraulic shores and trench boxes come with what's called a tabulated data sheet. This sheet documents the acceptable design load for the specific device being used. For instance, a box might be designed for depths of up to 20 feet in a Type B soil, but it may only support depths of 15 feet in a Type C soil. Now, these sheets need to be kept on site for reference. Make sure that the serial numbers on the sheet match the numbers on the box, and never modify a system without written consent from the manufacturer. No matter how many years' experience we have in the field, most of us aren't structural engineers, and we can't change a protective system's design without their input.
Back in 1979, I was a laborer out of Providence, Rhode Island, Local 271. I was a top man watching for the safety of the people inside. Unknowingly, the earth around the outside of the trench box gave way. We fell about, I would say, into the earth 10 feet. It undermined from water outside the trench underground. And it caused just a washout, and we went down. The only thing that was showing was like half of my right arm. And that's how they knew where we were. Through the quick response of other laborers, they dug us out. And, you know, we were scratched up a little, a couple of cuts from shovels, but we were all right, thank God. We learned, if we ever were buried, not to panic, because naturally you're using up the oxygen that would be in your body under a stressful condition. My message is to work safe in and around these trench areas, around machinery. If they foresee a condition, report it immediately to their foreman out on the job site.
Even after testing soil and determining which protective system will be used, problems can still occur. That's because there are still many other safety and health issues that need to be taken into consideration before digging and throughout working in an excavation. Things like surface encumbrances, utility lines, hazardous atmospheres, fall protection, roadway safety, and water accumulation, just to name a few. That's why it's so important to have a competent person on the job site at all times. My job doesn't end with inspecting site conditions, testing soils, and determining which protective system to use. I also have to test for hazardous atmospheres, monitor water removal equipment, inspect and evaluate excavations before a shift begins and throughout the day. I have to reassess after any type of weather change or when there are nearby sources of vibration. I need to pay close attention to whether the walls of a trench begin to sag or crack, or if the bottom bulges or water seeps in, or if a spoil pile has changed size, location, or placement. I pretty much have to keep an eye on things all day long. And if I see any sign that a protective system might fail, or find any other indication of a possible cave-in, it's my responsibility to make sure that all workers are removed from the area and that they stay away until all the necessary precautions have been taken. Surface encumbrances are common on trenching and excavation job sites. When's the last time you worked in an area where there wasn't a tree, a telephone pole, or pavement nearby? Any surface encumbrance that can create a hazard must be removed or supported as necessary to safeguard workers. Excavation work can also threaten the stability of adjoining buildings, walls, sidewalks, and pavements. In these cases, support systems such as shoring, bracing, or underpinning must be installed to ensure the stability of these structures. Once again, this is probably a good time to get a structural engineer involved. Let's face it, when performing excavation work, there's always a chance that underground utilities exist. Digging into underground utility lines can cause hazards like fires, explosions, flooding, electrical shocks or arcs, and toxin inhalation, all of which can cause serious injury or even death. Before digging, your employer must contact the utility companies or the property owners to locate sewer, telephone, fuel, electric, water lines, and any other utilities. If any underground utility lines or other installations exist, they must be protected, supported, de-energized, or removed. And don't forget, utilities can be overhead as well. Always maintain a minimum of 10-foot separating distance from overhead power lines. Mike, there's a broken pipe up there on the hill. Can you tell me a little bit about what happened there?
Well, we were ready to cut and cap it up on the top of the hill, and the water department said it was shut down. We put a whole ram through it. Ended up it wasn't shut down. We ended up filling up the entire area you see here that's been blasted out. About 100,000 gallons or so filled the area.
When working in a trench, you can't just jump into it and try to find a way to climb out later. There has to be a safe means of entry and exit for workers, like a ladder, stairway, ramp, or other safe means. You must be able to exit a trench quickly and within 25 feet of where you're working. It's also a good idea to make sure that there's at least one ladder per trench box so workers don't have to climb over or through spreaders to get out. Lifting equipment such as loader buckets and backhoe shovels are not safe means for entering and exiting a trench. If you use a ladder, it has to be inspected prior to use and it must be installed and secured properly. Ladders must also extend at least 3 feet above the landing surface. To use structural ramps, a competent person must design them and you need to be able to walk upright up the ramp.
Two plumbers who had been working in a trench were being hoisted to street level in the bucket of an excavator. As the excavator operator started to swing, the bucket jerked, causing one employee to fall approximately 14 feet. The employee struck his head on the pipe in the trench, causing a fatal injury.
Remember that you're not the only one working on the site. There may be other workers operating equipment or machinery, and they may not always see you. Be sure to make eye contact with the operator of any type of heavy equipment to let them know that you're there. And avoid the sweep, reach, dump, or path of any machinery or equipment too. Likewise, don't stand under any loads handled by lifting or digging equipment, or near any vehicle being loaded or unloaded. If there's mobile equipment operating next to or at the edge of an excavation, use some type of warning system such as barricades, hand or mechanical signals, or stop logs to let the operator know where the edge is. I also make it a habit to wear my reflective safety gear whenever I'm working around heavy equipment. It makes it that much easier for the operator to see me. Again, this is a requirement that many contractors are instituting, and I think it's a great idea. Excavation and trenching operations are often conducted on roads and highways. When you're working on or near a highway, it's important that you wear reflective safety gear. You need to make yourself stand out as much as possible in a situation where there are drivers and heavy equipment operators around you. Make sure that you inspect your work area frequently, and wherever possible, minimize the effect of excavation operations on traffic, such as changes in traffic patterns. New traffic patterns can be confusing to drivers, which can make them dangerous for you and your coworkers. Don't ever turn your back on traffic. Make sure that you see them even if they don't see you, and never stand in an open traffic lane. Show pedestrians and motorists where you expect them to go, and give motorists enough time to respond, but have a buffer space prior to the work area just in case. Think about how the weather conditions may affect visibility and stopping distance. Drivers have a harder time seeing in heavy rain or fog, and have a harder time stopping when it's snowing or sleeting. Make sure that there are enough warning devices such as cones or barrels on the roadways, and replace any damaged signs or devices that you see immediately. They're not going to be very effective if they're not visible. Everyone working on the site must have adequate training. Some states even require certification for flaggers or the use of police details for traffic control. But regardless of who's directing traffic, it's important that everyone know what their job is and where they should be. Perhaps most importantly, plan an escape route just in case an emergency does occur. Lifting and moving heavy loads with rigging cables and hooks are common operations on excavation sites, so it's important that safe rigging procedures are followed. Any rigging performed on site must be done under the supervision of a competent person who's experienced in rigging, and all rigging equipment must be inspected by a competent person prior to use. Chains used for lifting should be grade 80 or better and marked as such. And make sure that multi-leg cable slings and nylon slings are marked with their capacity as well. Never pull slings out from under a load with equipment. This can cause excessive abrasion. Remove damaged equipment immediately and notify your supervisor or the competent person that the equipment is unfit for use. Lastly, make sure that you're properly trained, and if you have a question, don't be afraid to ask. Most of the time, workers need to get from one side of the excavation to the other, so proper walkways must be provided. Any walkway that's 6 feet or more above a lower level should be equipped with guardrails to prevent falls. To avoid slip and fall accidents, make sure that all access and walking surfaces on equipment are oil and dirt free, and that slip-resistant finishes are maintained. Some areas may also require guardrails or tie-off on equipment for service personnel. All wells, pits, shafts, and remote excavations must be barricaded or covered and clearly marked so that workers don't fall in, and workers and materials should stay as far from the edge of the excavation as possible. Remember that many folks can be curious, especially kids. These barriers can help protect them as well. Another hazard to look for is loose rock, soil, stored materials, and equipment on the face of or near the excavation. These things can potentially fall or roll into the excavation or overload the edge and collapse the excavation walls. To prevent a spoil pile slide or possible trench collapse, scale the face of the excavation to remove any loose material and set up barricades to contain anything that might fall. Try to place spoil piles so that rainwater is diverted away from the excavation. And it's important to remember to keep everything, spoil, materials, and equipment at least 2 feet from the edge of the excavation. If there are workers that are higher on the slope of an excavation than other workers, workers on the lower level must be protected from falling, rolling, or sliding material or equipment. If you can't safely store the spoil on site, move it to a temporary site. The potential for atmospheric hazards can be found in many areas associated with excavation work. Potential atmospheric hazards include any atmosphere with less than 19.5% or more than 23.5% oxygen, sewer or natural gases, and hydrogen sulfide, typically found near landfills. Even the exhaust from machinery can cause the air to be hazardous. Trenches, pipes, manholes, catch basins, and foundation excavations with limited air movement can contain toxic or explosive atmospheres. And atmospheric hazards are especially dangerous in trenches because of the lack of air circulation. Before you enter an excavation that's more than 4 feet deep or any confined space, the competent person must test the air for oxygen deficiency and any other air hazards. Air monitoring must be repeated as often as necessary, sometimes even continuously, to ensure that the air remains safe for workers. Respiratory protection or mechanical ventilation and emergency rescue equipment must be readily available when working in these types of conditions. If you're working on an excavation site with potential atmospheric hazards, you will need emergency rescue equipment. This includes breathing apparatus, safety harness and line, or a basket stretcher. If you enter a deep and confined footing excavation, you must wear a harness with a lifeline, and the lifeline must be separate from any line used to handle materials. Don't ever attempt to rescue unless you're properly trained to do so. Otherwise, you could end up a victim yourself. Over 50% of confined space fatalities are would-be rescuers. Air isn't the only thing that can be contaminated on an excavation site. Soils can be contaminated too. It's good practice to perform a soil evaluation to make sure that the soil is not contaminated. Unfortunately, this isn't always done. So it may be up to you to catch any visible signs of contamination in the soil. Keep an eye out for oil sheens on standing water or chemical odors or staining of soil. Dead or distressed vegetation or buried containers, drums, and creosoted timbers could be indicators of contaminated soils. If you notice any of these warning signs, bring them to the attention of your supervisor immediately. Water accumulation in an excavation also makes for a dangerous situation for a number of reasons. Water softens the soil, which can lead to a cave-in, and makes getting out of an excavation in an emergency even more difficult for workers. Water accumulation in an excavation also creates electrical and drowning hazards. You should never work in an excavation with standing water or where water's accumulating unless adequate protections have been taken. Protections against water accumulation include installing special support or shield systems, using safety harnesses and lifelines, or removing the water with pumping equipment. Your site's competent person must monitor procedures against water accumulation to make sure that they're effective. Workers are not permitted in any excavation below the base or footing of a foundation or a retaining wall that's likely to be a danger to them. The only exceptions are when a support system, like shoring or shielding, is installed, or when the excavation is performed in stable rock, or when a registered professional engineer has determined that the excavation activity will not affect the structure nor pose a threat to the workers. Even after all precautions are taken and every safe work practice is carried out, you and every worker on site must be prepared in case the worst does happen, and you must be able to think and react quickly should an emergency occur. Emergencies typically come about quickly and without warning in excavation operations, and they can sometimes very easily result in injury or death. Excavation and trenching emergencies are not limited to just cave-ins. Material, equipment, or workers could fall into an excavation. A worker could succumb to a hazardous atmosphere, come in contact with an electrical line, or be struck or crushed by vehicles or equipment. What if the protective system fails? Would you know what to do in the event of an emergency? Luckily today, these guys are just practicing, but tomorrow it could be the real deal. And so the faster you react, the faster they can react. When you start working on a job site, make sure that you know the location of the nearest landline phone and any phone numbers that you might have to dial in your area. Remember that some places don't use 911 as their emergency number, and cell phones, they don't work on every job site. Your company should have an emergency action plan, and it must be communicated to every single worker. If you're not sure what the emergency action plan is for your site, don't be afraid to ask questions. Your knowledge could help prevent serious injury or even death. Trench and excavation retrievals are extremely dangerous operations. Additional collapses could occur, or utilities could collapse into unsupported trenches. Attempting to use equipment to dig a trapped worker out could result in decapitation or other very serious injuries. Trapped workers are frightened and can become frantic, and would-be rescuers react in much the same way. This puts the victims in even greater danger, and the rescuers could become victims themselves. This is why emergency retrieval should only be executed by people who are properly trained and equipped to perform them. So don't ever enter the trench during an emergency without proper training. You can do your part to help, though. Keep calm, secure the site prior to the rescue team's arrival. Shut down all equipment, move materials and tools away from the trench, and account for all workers on site. But once the emergency personnel arrive on the scene, back up and let them do their jobs. Rubberneckers can get in the way of trained rescue personnel, and that could cost valuable seconds, which could be the difference between life and death.
We have been activated once in central Massachusetts for an incident where a gentleman was working in a construction site, putting in a foundation, happened to have a very high water table in the area, and the gentleman got stuck in the mud approximately up to his waist or a little bit higher. The contractors worked approximately 2.5 hours prior to notifying the local fire department that there was actually an emergency on scene. Once the local fire department got activated, they arrived on scene and they activated our technical rescue team. We responded with all our members, and once we arrived on scene, it took us approximately a half hour to remove the victim from the mud. Some of the injuries we could have expected would have been like the crushing syndrome. Had it been like chest level, obviously the patient wouldn't have been able to expand his lungs or her lungs at the time. So we had to allow for that during the extrication so we don't have a sudden onslaught of blood rushing through the body where the body was compressed. People should follow the regulations and laws that are required of them, such as using a trench box when it's required. If the trench does get deep enough that it requires to be engineered, then they should have an engineer do it. If they follow most of the regulations, then they really shouldn't have a need for our team to respond, which is the way we would rather see it.
Sometimes you can stop an emergency before it even occurs. When in doubt, get out. If you see anything about the excavation that looks unsafe or dangerous, get yourself and your coworkers to a safe place as quickly as possible. Notify your competent person and let him or her know of your concerns. We're trained to deal with these types of situations and can determine the next steps to take to ensure your safety. Remember, working smarter means working safer, and that makes everybody's job a lot easier.